Hey, hello and welcome to today's GFG problem of the day. Hope you all are doing well. So let's say today's problem, sum of nodes on the longest path from root to leaf node. Okay. So what the problem is saying is, we'll be given a binary tree. Okay, a binary tree. And what we want to do is we want to find the sum of all nodes of the longest path. For example, we need to find the longest path, right? And we have to return its sum. So this is the ask. This is the ask. Okay. So what is the longest path here? So there are two longest paths of the same length. So 4, 5, 3, 3, right? And another is this one. 4216. So both the length, right? For this, both the length is 4. That is same, right? So now what the problem is saying is we want to return the sum of all nodes of the longest path, right? And if there exist two such paths of the same length, of the same longest length, then we have to return the one with the maximum sum. So in this case, if you see, what is the sum over here? 4 plus 5, 9, 9 plus 3, 12, 12 plus 3, 15, right? And what is the sum here? 4 plus 2, 6, 7, and 7 plus 6, 13, 13. So we need to return this 15. Okay. Now I hope you've got the problem. Now let's see what can be the solution, right? So what we can do here is we will be traversing this binary tree in post order. Okay, in post order, and we'll be calculating. Okay, for example, let's say what we're going to do. For example, we come to the root here. This is the root, right? So we are going to go to the left subtree, right? To the left subtree, we will keep on going to the left subtree, right? So here we come and then we go to the left subtree, left child of 7. It is going to be null. So what we're going to do once we reach the leaf node, right? Once we go to the leaf node and we go to the left child again when it is null. So what we're going to return here, we are going to return two things. We are going to return a pair. A pair of what? A pair of height and the sum of the nodes up till this node, up till the current node. Sum of the node. For example, here. So what from here it is null, right? So what we're going to return here, the height is going to be 0 and the sum also it is going to be 0. Sum of nodes until this current node. So for null, definitely we are going to return this, right? So we come here to 7 again, right? We go to the right child of 7, right? We go to the right child of 7. Again, here it is null, right? So what we're going to return? Again, we are going to return 0 and 0, right? 0 and 0, right? So when we come to 7 here now, we are done with the processing of left and right child of 7, right? Now what we're going to do? We are going to check the height of both. For example, this is the left, right? This is the left we got, this one, right? And this is the right we got from the right child, right? So we are going to compare the left and the height of the heights of the left and right children. Okay, the left and the height of the left and the right children, right? So in this case, it is same, right? 0 and 0, it is same, right? So what we're going to do? We are going to now take that means we have found a path in the right and left child wherein the height is same. So what we're going to do in this case, we are going to return the maximum. We are going to use the maximum, right? Out of the sum of nodes, out of the sum of nodes. For example, here 0, 0, it is going to be 0 only, right? So, and what we're going to return from 7, what we're going to return? What we are going to return is, we are going to return the height. So what is height of 7? It is 1, right? So what we're going to do, as the height is same for both the left and right child, okay, so we can take either of them. Height we're going to do 0 plus 1, the height of 7, right? Which turns out to be 1, which turns out to be 1. And what is the sum of the nodes? So what we're going to do in this case, max of left and right, sum, right? Which is 0, 0 plus 7, 0 plus 7, 7 the value of this current node. So 0 plus 7, 7. So we are going to return 1, 1 comma 7 to the parent of 7, right? To the parent of 7. Now we came here, we have processed the left child. So you'll understand better when we move ahead. Okay. So here now we have processed the left child of 2, right? Now we'll go to the right child of 2, right? So here we come, we found 1, right? So we are going to keep on going. Right? 6, we came here. Again, 6, we are going to go to the left child. Okay, it is going to return 0, 0, right? We'll go to the right child of 6. It is going to return 0, 0. Height and the sum of the node values, right? Sum of the node values, sum, right? So here we have processed the left and right child of 6, right? Now again, the heights are same for both left and right child. So what we are going to do? We are going to return whichever height we can take, we can take, right? Because height is same. 0 plus 1, right? As height. Height 1, that is the height of 6, right? So 6 and the sum of nodes. So it is 0 and 0, max of 0 and 0, right? Which is 0 only plus 6. So we are going to return to the parent 1 comma 6, height 1 and the sum is 6. Okay. So now we come here, right? So on 1, right? So now we have processed what? The left child of 1, right? We have processed the left child of 1. There's no right child of 1, right? So what we're going to do in this case? In this case, the right child of 1 is going to return what? For example, here this is a case, right? This was a case, right? So it had left child and right child was missing, right? So what is right child going to return us? 0, 0, as it is null, right? Right? As the right child of 1 is null, it is going to return 0, 0 to 1. right? And what is 6 returning? 6 is returning 1 comma 6. Okay, now on 1, now we are going to check whose whose height is more, is greater, right? Is it left child's height is greater or right child's height is greater, or both the height is same? So here in this case, left child's height is greater, right? So what we're going to do in this case? So coming back to here, right? What we're going to do? Left child's height is greater. So what we're going to do? One, we will take the height of the left child, right? We'll take the height of the left child 1 plus we'll add its own height 1, right? And this is the height, right? This is the height. And what we're going to return? We want to return the sum as well. So in this case, anyways, the height of the left subtree is greater. So we are going to consider its sum only. Because what we want to consider? We want to consider the sum of longest path, right? So we won't consider the height of the sum of right child, right? Because the height of left child is greater, we are going to consider the sum of this only, of the left child only. Okay, it is 6. So we are going to add 6 plus whatever is the root dot data, right? It is 1 here. So 6 plus 1, 7. So what we are going to return 1, 2, comma 7 to its parent. So we are going to return 2, comma 7 to its parent, 2, comma 7, right? We have written 2, comma 7 to its parent. Now we have processed, right? We have processed the right child and the left child and right child of 2. Here now what we're going to check on 2, right? What we got? So if we consider here, right, 2. So what we're getting here, from the right child we are getting 2, comma 7. From the left child we are getting 1, comma 7. So now what we're going to do again on this path, on this node, we are going to compare the heights of the left and right child, right? So definitely here the height of right child is more. So we are going to, so this is going to win. We are going to consider this only. So what we're going to do when we return to the parent, so we are going to add the height of this node to this whatever the right child is returning. So the right child what is returning 2 height, right? Plus we're going to add the height of 2, that is 1, right? And what we're going to do, we're going to consider this sum 7, right? 7 plus 2, its own value, right? 7 plus 2. So what we're going to return 3 comma 9 to the parent of 2, to the parent of 2. So what we're returning 3 comma 9 to the parent of 2. Okay, to the parent of 2. Now we have processed the left subtree of 4. Now we are going to go to the right subtree. So we are going to go to 5, then we are going to go to 2, 5 from, then we are going to go to 2. So 2 again, we are going to, what it is going to return 0, comma 0, right? And it is going to return 0, comma 0 here. So here, since 2 didn't have any left and right child, it returns 0, comma 0, 0, comma 0. And what we're going to return to 5 now? The height of 2, that is 1, and the sum of 2, right? To 1, comma 2, we are going to return to 5, right? We have processed the left subtree of 5. Now we're going to go to the right subtree, right? 3. Again, 3, we're going to go to left. It does not have any child. So it is going to return what? 0, comma 0. It is going to return 0, comma 0. We'll go to the right child of 3, right? So what it is going to, we went, and again, it is going to do the same, right? It is going to return 0, comma 0, 0, comma 0 here, right? So 0, comma 0 to return. So here, what we are going to return to its parent, its own height, right? 1, comma, the sum, the node value, 1, comma 3 to the parent of 3, right? So we here have on this, right? What is the case now? What is the case if we see? Let me write this case. So here the case is what? 3 from the left child we got 0, comma 0 as it didn't have any right, the left child. From right child what we are getting 1, comma 3. Now we are going to compare the left and the heights of left and right child, right? Right children. So here the right children wins because it is adding more height. So what we are going to return to the parent? We are going to take the height of the right child 1 plus its own we are going to add in the height 1, right? And what we're going to do, we'll take the sum of the right child till now 3 plus add its own 3. So what we're going to return 2, comma 6. We are going to return 2, comma 6 to the parent, 2, comma 6, right? Now again what we have in case here, we have 5 node here, and from left child we are getting 1, comma 2, and from right child we are getting what? We are getting 2, comma 6, right? So we are going to compare the heights of left and right child. Again, the height of right child is more. So we are going to what? We are going to return what? We are going to return, we'll take the height of the right child, sorry, the height of the right child 2, right? Plus add its own height, right? Plus 1, right? And take the sum 6, 6 and plus 6 plus 5, its own, right? Its own value. So it comes around 3, comma 11. So we are going to return 3, comma 11 to the parent. So what we are going to return 3, comma, yeah, 3, comma 11 to the parent, 3, comma 11. Right. Now we come to this root node. Now see, I'll explain you the case. It is what? For example, what is a root node 4, right? So from left child it is getting 3, comma 9, and from right child it is getting 3, comma 11. So here we are going to compare the heights of both the left and right subtrees. It is same, right? It is same. So what we are going to do in this case, we are going to consider the one with the maximum sum, right? When the heights are same, we are going to consider the path whose sum is maximum. So it is going to be 11, right? So what we are going to do, simply return 11 plus its own value 4, that is 50. Okay, so this is the intuition. I hope you got the intuition. Let's go to the code now. And before going to the code, I would request you to subscribe to my channel. Now, once we implement the code, you will understand better. Okay. So I'll show you the Java code followed by C++. Okay. So please subscribe to my channel. Okay. Thanks. So now what we are going to do, we are going to write for example, this is going to return, let's say, yeah, let's do one thing. It is going to return the result, for example. Okay. Integer and solve node root. Okay. Now we are going to check for the base condition first. We are going to write the base condition. When example, for example, this is the leaf node, right? You can take any leaf node. For example, it is 2, right? So when we go to the left child, right? When we go to the left child, it does not have any node, right? So it is going to return 0, 0, height 0 and sum 0. Okay. So that's what we are going to take care. If root equal to null, so we are going to return what? We are going to create an array. It is nothing but integer result equal to new array list result dot add. We're going to add 0, the height, and the sum as also 0, right? And we're going to return the result, right? So here this is a base condition. Now what we're going to do, we are going to go to the left child, right? For example, solve root dot left. We are going to the right to the left, and we'll also go to the right, right, right. So now we have the left and right values, right? So it is this case, right? For example, this was 4, right? And we have got values from the left child 3, 9 and values from the right child 3, 11, right? So here, so root is what now? Root is 4. Root is 4 and we have left and right, left and right. So left and right is what? Left and right, we have this, right? Now we are going to compare the heights, right? We are going to compare the heights. If left dot get 0, so height is at 0th location, right? So if it is less than right child's height, right? So we're going to consider the right child. Right child wins here. So what we're going to return? So right dot set. We are going to first set the height, right? We're going to first set the height. So what it is going to be? Right dot get 0, right? Whatever is the right child's height plus its own height plus the root node's height, right? So plus 1 we did, right? And we also want to set the sum, right? So what we're going to do? Right dot get sum, right? That is the second value plus its own value, right? So I hope you're getting here. So what we're doing, so the height, for example, in this case, right? In this case, for example, let's consider it returned 2, right? It returned 2 and here it returned 3, right? It returned 3 here. So what you're going to do, we are taking the height of the right child plus we are adding 1 of its own height, right? 3 plus 1. That's what we did here, right? We took the height of the right subtree, right child, and added 1, added its own height. And what else we did? We took this 11, plus its own value, plus 4. Plus 4 we did, right? 11 plus 4 we did. 11 plus 4 we did. Okay, so I'm returning the right. Okay, so this way, for example, now if let's write, okay, if the height of left child is greater, right? So what we are going to do, simply we are going to consider the left child height and the sum, left, 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 right? And then we are going to return left only, else, right? This was a case when the left child height is greater than the right child height, right? Else, if the heights are same, for example, in this case, yeah, in this case, it is written in the same heights, right? The left child and the right child written in the same heights, 3, 3. So what we're going to do, we can consider any one, right? So in case of the, so what we're going to do, yeah. So we'll take, for example, right? What we can do, we can consider any one side because it is same only, right? So what we're going to do, right? For example, right dot set 0, right? You can take any one side, right? Either right or left, it is same only, 0 plus add its own height. And what you're going to do, right dot set 1. Now we are going to take the maximum of these two, right? Even the height is same, the maximum of the sum, right? We're going to take the maximum of sum of the left and right. Math dot max, left dot get 1, right dot get 1, right? So this is the maximum we are going to do plus add its own root dot data, add its own value and return right. Okay. So in this way, I think the problem will be solved. Okay. So what we can do here is, okay, yeah, here, right? So what we want to do, we want to take the result and we'll return the maximum path, right? This result will ensure that it has the maximum sum path. Maximum sum we are going to return. Yes, that's submitted. Yes, the test cases are executed. Now let's quickly see the C++ code. Before that, I'll request you to subscribe to my channel. Okay. So here is a C++ code. Okay. So here we are taking vector, right? So here we have the base condition null pointer. If it is, then we are going to return the height 0 and sum as 0. Okay. And here we are having the left, we are having the left child value and the right child value, right? We are processing the left tree subtrees and right subtrees. Now we are checking here. If the left, if the height of the left child is greater than the height of the right child, then increment the uh, height of the left child, right? Right. So that is we are also considering the root's height here, and one is we are adding the root dot data to the sum, and then we are returning left, right? If the right child is greater, then we are incrementing the height of the right child, and we are adding the root dot data to the sum till now to the sum of the right child, and then we are returning the right. If it is same, we are going to increment the height, right? We are going to increment the height and we are going to take this maximum. We are going to take the sum of the maximum of the left and right. And we are going to add the root dot data to that maximum. Okay. And then we are going to return left. Okay. So I hope you have got the solution. Let me submit it. It is going to work definitely. Okay. Yes, it is. It has worked. Okay. Thanks for watching. Have a happy, healthy, and a great day. Thank you so much.